for the 720s for this room because of the projectors. There's both. Yeah, go ahead and start recording. Do you got a mic up? Oh, should be this one? Yeah. Okay, that's one, Jay. You good? Is it on?
I think so. Let's see.
Yeah. Yeah, good audio for now? See it? Face check into the mic, please.
Hello?
Okay, you're good.
Need to be higher?
No, you're good.
Okay.
I'm on radio, so hope somebody. Okay.
All right, everybody. Well, thanks for coming out today. My name is Anthony DiDonato. We'll be talking about virtualization-based security. It's a pretty relevant topic. It's something I'm very passionate about. I've spent about 20 years working in information technology, mostly around virtualization. So I have some of my contact information up here if you'd like to reach out later. You can catch me on LinkedIn or Twitter. If you need anything afterwards, you can ask me. I have business cards as well. So from an agenda perspective, we're just going to go through a couple of different things. We're going to detonate some malware just to prove a point and make a differentiation between detection and isolation. Detection versus isolation and containment. A lot of the solutions out there today talk about how advanced detection engines they have. They talk about AI, they talk about machine learning, they talk about all these different ways to detect things, but inevitably detection fails, so we'll talk about that a little bit. We're also going to talk about virtualization-based security and what it is, why we have it, and how it works. Then I'm going to demonstrate a couple of currently available solutions, and we'll discuss the pros and cons. So I'd like to kick off with a demo, but I also want to preface this with a little bit of information. I mean, even today, something as simple as WannaCry or any kind of crypto locker solution or system that's out there is still hitting people. So all these new technologies are out there, all these new solutions are out there, and people are still getting owned. A lot of them still actually own these Nextgen AV solutions. So there are techniques to protect yourself from this, but people are not adopting them. So this is to really raise awareness. Two in particular I'd like to talk about is the attack on the Olympics. It was a targeted attack, basic North Korea versus South Korea, trying to knock their systems offline to ruin their day. So we're going to detonate that malware today. We're also just going to go through basic WannaCry crypto locker solution that's out there and how we protect ourselves from that. I apologize if I'm a little distracted. There's a lot of moving around going on here. So I just have can you see my screen over there? Or?
Yep.
My presentation's still active, huh? All right. Put this up in full screen. So Windows 10 platform, I have a solution installed called Bromium. Bromium is basically virtualization-based security. We'll go over what that is exactly as we go through this talk, but I just want to do a quick demo and show you what we're talking about here. So I have a staged demo. I have malware installed, or malware available, particularly Olympic Destroyer. If I were to be a victim of this malware attack, it would effectively wipe my system and destroy everything. Effectively, it goes down, deletes your shadow copies, deletes your backups, modifies your boot configuration, and effectively destroys your entire operating system. So I'm running this freely because I'm not worried about that occurring. Why I'm not worried about that occurring is because this application, Olympic Destroyer, is actually running in a virtual machine. You can see over here in this little live view screen, it's running. I can let it run all day. It doesn't really take that much time. So I have it running this screen back here. I'm going to kill it. While it's running, I'm capturing all of the threat intelligence, all of the attack surface that's being exposed, and all of the API calls that are occurring in the background. Give me a second here. So while that's detonating in the background, I'm capturing threat intelligence about it. I'm capturing as much of the kill chain as possible. Obviously, I won't know how it got onto my system, how it was delivered, but after it reached my system, I'm able to capture everything that it's doing there, completely contained. So I let it execute, I let it run its course, and I capture all the information relative to it. So I'm detonating absolutely malicious wiper-style malware on my system without any threat at all. So let's go back here. One other demo that I'd like to show you is WannaCry. Again, still relevant today. You would think after years and years of being run and captured and signatures delivered to antivirus vendors, they still can't seem to stop this software from destroying people's environments. So on a typical day, you're running through your normal day-to-day activity, you're reading resumes, you're working on your spreadsheets. You get a resume in particular, it's confidential. Maybe they password protected it because they wanted to protect that information in transit. I receive the resume, I enter the password, I start to review that resume. This is pretty normal activity. This is what users are doing all day. But attackers are effectively embedding macros in these documents because Office across the board has its own scripting engine. There are a lot of different applications that have their own scripting engine. So because they have scripting engines, they're exploited, and they're often exploited. It's pretty common for red teams to even use these tactics and get right past Nextgen AV, current AV, intrusion detection, you name it. So while we're going through this day-to-day process, maybe making notes in the document, send to Bob. In the background, this malware is actually executing. If you notice here, I got this wonderful pop-up screen. Most threats are not going to tell you they're on your system. But when you talk about WannaCry or things like that, they want to make it obvious because they're trying to get some money from you. If you notice, the pop-up screen is moving around, but it can't seem to get out of this container. So container is a pretty interesting term, but this is a little more than just a regular container. So you can see that WannaCry is launched. It's encrypted all my files. I contact IT. It even has a nag screen, so it keeps coming back. So if I wanted to save my contents, maybe I click save. I don't need to. So all of those things occurred, and in the background, I was tracking them. Still have Olympic Destroyer running, trying to take out my system. So I've launched WannaCry and Olympic Destroyer in the matter of 2 minutes, and I'm still up and running. The reason I'm still up and running is because it created a hardware-based isolation environment. It's a micro VM, and we'll talk about the details of that. So again, just show you the kill chain real quick. Again, not full kill chain, but definitely a kill chain that occurred on my system. Tells me everything that occurred, tells me what processes were invoked, and any dropped and executed malicious binaries. So I have all the MD5s, SHA-1, SHA-256. If I want to take those and send them up to a virus total or something like that, I can go investigate what these are. All right. So if I were to do that same demo without virtualization-based security in place, my demo would have been over very quickly. So I want to talk a little bit about Nextgen AV and antivirus in general. While they get better and better every day, literally every day, they still have a lot to be desired. In particular, it requires incident response. The attack occurs, someone gets alerted, they have to go do something about it. A lot of times they're doing nuke and pave. So instead of really doing the investigation and finding out what occurred, how it got there, and what the actual effects were, they just wipe the system and move on because the user needs to get back to work. So they miss out on a lot of that threat intelligence. They miss out on a lot of things. You have a patient zero. That first person was affected, regardless of whether you detected and grabbed that signature. So again, patient zero, incident response. You have antivirus out on your system. It typically slows your system down. So if you're an executive or someone with power in the organization, you can say, I need to turn this off, or I need you to put an exclusion in here. Do whatever you need to do to make this faster. Those exceptions basically remove all aspects of security. They'll say things like, I need to launch this application. It runs a macro. I need macros enabled. Okay, you see where this is going. Oh, every time I download this file, it writes to the temp directory. It's temporary. We don't care. Put an exclusion in. All bad ideas. Then there's naturally the administrative overhead. It costs money to support these systems. It's an arms race, and no one's winning. Then you have SIM, you have the Splunks and the ArcSights of the world. And if you have those in your environment, you know they're incredibly expensive. They're full of noise, and there's a lot of false positives. That doesn't mean they're ineffective. It just means there's a lot of work and money that goes into supporting them. And then obviously, if you've ever done any red teaming or adversarial training, or if you actually are an attacker, you know there's a lot of ways to get around AV. There's a lot of ways to get around application whitelisting, firewalls, proxies, you name it. There's always a way around. And most of these antivirus vendors will sell you their software. They don't care who you are or where you got it. So you just install it in your lab and make sure that your malware actually executes in their environment, especially if it is a targeted attack. So isolation and containment provides another layer of security, a trusted computing model. Basically, we're not worried about detection so much. We need detection, obviously, but we don't rely on detection for protection. So we're leveraging the hypervisor on the endpoint, as opposed to taking that software, passing it through a sandbox, hoping it executes, and hoping we capture it, and passing it on. We actually put the hypervisor on the endpoint. There's a couple different approaches. There's more than one solution out there. I'm going to talk about two today. But when we talk about a trusted computing model, what are we actually protecting? We're protecting the master boot record. We're protecting ourselves from direct memory attacks. And we're trying to protect the kernel effectively. An attacker typically wants to capture your secrets. Secrets could be intellectual property, your credentials, some of your information on customers or your employees. And then obviously, let's talk about some solutions. So Microsoft, be it as they are, they do a lot of things well, and they implemented a solution for virtualization-based security around protecting certain components of their operating system. So people typically want to capture your credentials. They want to capture your intellectual property, as we talked about. So Microsoft says, okay, we know they're coming. They've been doing it for 15 years. They've been exploiting features in our operating system. Has anyone ever run a pass the hash attack? Anybody? Okay. So it's been around for 15 plus years. It's not an exploit, or I'm sorry, it's not so much of a design flaw. It's part of their operating system. It's how they want it to operate. You log onto the operating system, you want to log on to another operating system's resources, you have to pass credentials along at some point, or you have to be challenged. If users were challenged every time, then obviously they'd have to log in every time, and it would be a painful experience. So to make it easier, they pass that hash along. They pass along credentials, whether it's a Kerberos ticket, whether it's any type of credentials. It doesn't even matter at this point. So hardware-based or virtualization-based security takes the traditional model where you have, it's a little tough to see this slide, you have your device hardware. On top of it, you have your operating system, which is effectively the kernel. You have your services, and then you have your applications running on top of it. Most attackers, what they're trying to do, now obviously if you're running, executables, that's one thing, but a lot of attackers are using fileless malware. They're not even writing to disk anymore. So they're just running a process in memory or getting into the system and injecting into other processes' memory. When they do that, they're effectively extending the user space into the kernel space. And they typically do this through drivers. Now, there's more than one way to attack, but that's one of the common ways to attack. So Microsoft says, okay, let's assume that this existing model doesn't work. NTOS kernel is basically not trusted anymore. We don't want to trust it anymore because we know it's exploitable. It's very easily exploitable. So they create a secure kernel. So the secure kernel runs in parallel to the NTOS kernel. And through that secure kernel, they create trustlets. And what the trustlet allows them to do is say, these applications or processes or services are allowed to talk to the secure kernel, but they're not allowed to talk to the NTOS kernel. And the NTOS kernel is not allowed to talk to them. And they implement this solution through virtualization. Effectively, Microsoft is using Hyper-V to create a micro VM. Effectively, I don't want to debate the semantics of that one because it's not necessarily a VM. It's actually a trustlet, but they're using Hyper-V to run the secure kernel and to run another version of LSAS. Now, LSAS on the NTOS kernel, or the legacy model, so to speak, is the local security authority subsystem. It's effectively what you use to authenticate. So that process runs as the system and has the ability to access secrets, and I'll show you that through another demo. The secure kernel does not talk to the NTOS kernel, also runs as the system, but talks directly to the hardware. And it does that through virtual trust levels. If you've heard of Ring 0 or Ring 3, it's a computing model trust basis. We're saying Ring 0 is the most trusted, Ring 3 is the least trusted. The further away from the circle you get, the less trusted you are. That really didn't work too well because most people don't know where Ring 1 and Ring 2 went, right? Or what's below there. You have the BIOS, you have the UEFI. Those are also places that are part of the attack surface. So what they're doing is implementing this virtual trust level. Virtual trust level 0 is the legacy model. We don't trust that at all. VTL1 is more trusted, which is where the secure kernel is running. So if you take the approach of saying, I have malicious code, I'm going to attack your operating system, and now I want to also try to attack the secure kernel. It's not allowed because there's no trust from that system into the trusted system. It's a pretty simple diagram, but I'm just trying to build the story here. So VTL0 is not trusted by VTL1. They're both running on the same hardware. They take the same approach with their browser. And when I say their browser, I mean Edge. Internet Explorer is not included in virtualization-based security, even though it's more prolific. So Microsoft is saying, we know that's junk. We want to make it more secure. Problem is, corporate America and most users are not going to get away from it. People that are in a security space obviously may stay away from it or may plan to attack it a little more often. But they take the same approach. So they say, we have a virtual trust level of 0 for the operating system. We'll allow you to run Edge in that VTL0. But if you need to run secure mode, we'll create a micro VM for Edge. So your browsing activity runs in another VM. That feature is called Application Guard. So if that browser tries to talk back to the NTOS kernel on the VTL0, it'll be blocked as well. So let's talk about this in action and just basically show it to you. So we talked about LSAS, we talked about LSA ISO, which is effectively Credential Guard. So LSA ISO.exe is the isolated user mode version of LSAS. So let's pause out of there. Okay, that shut down for some reason. Well, let me show it to you while that's spinning up. I'll show you what it looks like on the regular system. So you go into Task Manager, you can go into Process Explorer. It's really arbitrary. But on a regular system, we have our processes running, and we have the LSAS process. So this is local security authority subsystem. When you authenticate, this is where your credentials are being processed. And if you've run MemCats, if you've done any kind of pass the hash attack, you know that this is your target. Effectively, what you're trying to do is capture this process, check if the user is an administrator, elevate into the system context, and then dump the memory, because the privilege of debug is associated with the system. Even a user who's an administrator with user access control enabled won't have that process until they actually run a process as memory. So they won't have that privilege. So let's see if we can get this other one going here. Here we go. All right. So if I'm on this operating system, this actually has Credential Guard installed. And the way that I can tell that is just by launching the system information. I have to launch it as an administrator to see all the features. So when I go onto that system, launch this. This is not the attack. This is just more of a validation of that it's installed. So I have to be running in UEFI. I have to have secure boot enabled. because without these things, I can't effectively protect the system because I cannot support a TPM. So I need secure boot, I need UEFI, and then I need to have a VBS installed. So in this scenario, I have it up and running. So you'll see here in system information, it'll say virtualization-based security is running. It's a little bit tiny. I have secure boot enabled, DMA protection. DMA is direct memory access. Things like PCI devices and USB devices that are going to convert at some point. I have credential guard enabled, and I also have hypervisor enforced code integrity. So effectively what I'm saying there is if I load a driver and it doesn't pass this check in a VM, I'm not going to allow it in. It does that through signing, and that signing occurs by Microsoft. They don't allow third parties to sign drivers anymore when it comes to this solution. So if you want to work in the secure kernel, you have to be signed by Microsoft and Microsoft only. So this is the basic check. If I have, let's see here. In this scenario, because I have Credential Guard enabled, you'll see LSA, LSO. I don't know if that's clear enough for you out there, but you can see there's LSAS running. So they're running in parallel. They're completely separate processes. If I come over here, and let's see here, we have, let's clear that out. If I go through the process of dumping LSAS. So LSAS, this is a proc dump from Mark Rasinovich or the System Internals tools. Take the LSAS process and dump the memory on it. It's pretty fast, it's pretty easy. I can then take that dump, run it through MemCats and read all the information that's in it. So that's a pretty common attack. It's not done manually, but it's a pretty easy process. If I try the same thing with LSAS LSO, which is the counterpart, secure isolated user mode version of LSAS, it can't even see the process. So running as the administrator, I cannot see that process because it's isolated and I'm on a system that's not trusted, even though I'm on the same actual host. So I can't dump the memory from that, so I'm effectively protected. Microsoft tried to protect it. They did a really good job at building a system, leveraging the right technology, isolating it, signing it, trying to create a barrier between the two. What do you think the problem with that was? At some point, it's too hard. So they said, we got to fix this. We have to make it easier. So they give vendors the ability to create their own security support providers. It's called an SSP. And that SSP has the ability to interact with the LSAS system. So effectively, legacy applications are going to try to authenticate. And if they're trying to authenticate and they need to get out into the other space, they need to be able to pass blob storage. So that they had to create a channel open to communicate with that process. When you communicate with that process, LSAS, LSO, it's protected. But your application coming from where you are is not. It's like coming in from the mud. You're coming in, you have mud all over you, you're going to go into this secure kernel, it's going to clean you up. But in process, you're still accessible. So we'll demonstrate that as well. So I have a lot of windows here that have been shrunken down. Oh, let me demonstrate something else really quick. So if I am right here, if I say, who am I? I'm effectively a user. So we talked about these attacks. If you want to go through and dump memory from LSAS, you have to go from administrator to system. Wow, that was a fast 15 minutes. So ps exec -s -i -d. And let's just say I want to launch command.exe. I'm effectively able to launch that process and change my context from from user to system. Once I've done that, and how simply I've done that, because I'm an administrator, I can do anything I want on that system, I can now dump the memory. So, real quick, we have MemCats. And MemCats here, anybody never heard of MemCats? Okay. So effectively what you have here is a tool that's been around for 15 years. It's had all these components that I'm going to demonstrate available since 2014 in particular. So if I were to log on to MemCats, I could go through and do privilege debug, which is a pretty common approach. It's required to debug memory. I'm not running a system, sorry. Okay, once I'm in privileged debug mode, I have access to memory. What I'm going to do now is I'm going to load the security provider that MemCat's created. So it's memSSP. Once that's loaded, it's running in memory. There's no file on the system, and it will survive as long as the system is up and hasn't been rebooted. If I wanted to establish persistence, I would obviously just get the files on the system or somewhere on the network and allow it to restart every time it runs. So once a user on that system logs on or logs off, so if I were to switch users or sign out, when I sign back in, it's going to capture those credentials in memory before it ever makes it to LSAS or before it ever makes it to LSA, LSO. So I'm going to log back in. Apologize for the delay. Once I've done that, because it's running in that, it's already running in memory, I can go in here and take a look at it. So if I say type, and I do take the LSA log, you'll see that it captured my passwords even though I had Credential Guard installed. So the whole point of Credential Guard and virtualization-based security is to create an isolated environment. But coming from the untrusted side to the trusted side, you're still exposed. So effectively, you have this security model that's probably better than anything out there. If you're coming down from the internet or down from an untrusted source, you have the ability to protect that data through isolation and containment. But if you have the untrusted side still unprotected and they're going the other direction, it's widely exposed. So I only had 20 minutes to get through this topic, but I showed you a lot of different things. We launched a wiper. We launched WannaCry. We've taken Credential Guard, which is supposed to protect you, and shown that it's not actually capable of truly protecting you because you still have the untrusted side. There are solutions to these situations, complete lockdown, but you really have to go back and wipe your whole system to start over, put a baseline on there, make sure it's a protected system, implement TPMs, update your UEFI, and then obviously have some kind of Nextgen AV plus virtualization-based. It's a long VBS. All right, so that's a quick 20 minutes. I've had just enough coffee to make me talk too fast. So if you have any questions, shoot. But if not, we'll be downstairs at the booth.